Hello there, and welcome to the Sleepy Science Channel. Tonight we explore one of the most remarkable frontiers of all, the Milky Way galaxy, our cosmic home. For centuries, people believed the stars above were fixed, unchanging, eternal. But science has begun to reveal something far more astonishing. The galaxy is alive with motion. 200 billion stars drift through space, each one orbiting a common center we cannot see. They are born in clouds of dust, burn for billions of years, and scatter their light across the void. The spiral we call home is not static. It breathes, grows, and evolves across deep time. The more we learn, the more humbling it becomes. We are not separate from this vast structure. We are made of it. Every atom in your body was forged inside ancient stars and scattered into space when they died. The galaxy shaped us, and we carry its memory within. If you enjoy these quiet journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here, too. One sleepy soul at a time. But for now, just breathe. Allow your eyes to grow heavy and your mind to settle. Let's begin. Chapter 1. The Shape of Home. Far above the sleeping Earth, the Milky Way unfolds like a slow-turning compass of light. From edge to edge, it spans 100,000 light-years, a number too large to picture, so think instead of time. If you could travel at the speed of light, you'd still need 100,000 years to cross from one rim to the other. Even then, you'd only see a fraction of its stars. Astronomers call it a barred spiral galaxy. At its center, a faint golden bar of stars stretches across the core, feeding two grand arms that curl outward. These arms, named Perseus, Scutum Centaurus, and Carina Sagittarius, sweep through space like long ribbons of starlight. Between them, smaller branches twist and fade, like tributaries of a glowing river. Our solar system lives in one of those quiet side streets, called the Orion Spur. We are not near the center, not near the edge, but somewhere in between, a calm suburb of a busy city. It's the perfect place for life to unfold without too much chaos. Here, the night sky is deep and peaceful, yet filled with the faint glow of countless suns. Seen from within, the Milky Way looks like a mist, a diffuse band arching overhead. Seen from outside, it would resemble a wide, thin disk with a swollen middle, wrapped in a faint halo. The disk is the stage where most of the action happens. Stars forming, planets circling, light forever traveling outward. It's only 1,000 light-years thick, though that sounds enormous. It's a paper-thin layer compared to its width. Inside the disk lies structure upon structure. There is the thin disk, where young, bright stars orbit neatly, and the thick disk, older and puffier, with stars that wander slightly above and below the plane. Above them stretches the halo, an enormous sphere of sparse, ancient stars, relics from the galaxy's youth. Scattered through it are globular clusters, each holding hundreds of thousands of suns bound tightly together. Some of those clusters are more than 12 billion years old, nearly as ancient as the universe itself. Imagine standing within one of those clusters, a sky so crowded that night would never be dark. Every direction would blaze with starlight, so close that shadows could not exist. Yet from our quiet corner of the galaxy, we see them only as faint specks, dim pearls suspended in black. At the heart of the Milky Way lies a mystery, a massive, invisible weight known as Sagittarius A star, the galaxy's central black hole. It holds 4 million times the mass of our Sun, but fits within a region smaller than Mercury's orbit. We cannot see it directly, but we can watch its influence. Nearby stars whip around it in perfect obedience, their orbits revealing the hidden gravity that binds them. To astronomers, those orbits are signatures, precise, rhythmic, predictable. To listeners like us, they are poetry in motion. Each star's path is a verse, repeating every few decades, tracing the outline of an invisible heart. Around that heart swirls a haze of gas and dust. Sometimes it glows in radio and infrared light when matter drifts too close, spiraling inward and vanishing. Occasionally, a flare erupts, a brief exhale of energy, then silence again. The center of our galaxy, for now, is mostly calm. But the shape of the Milky Way is not static. Its arms drift, its stars migrate, its outer edge warps like a slow wave on water. The galaxy is alive with motion. Gas clouds fall inward. Old stars drift outward. Even the spiral arms themselves are not fixed. They are density waves, patterns that move through the disk like ripples on a pond. When a wave passes through a region of gas, it compresses it slightly, and the gas collapses to form new stars. Those newborn stars light up the arms briefly before aging and fading, while the pattern keeps moving. So, the arms are not highways lined with the same stars forever. They are moving gatherings that drift on. Between the arms, space is quieter. Older stars wander freely, less dense, less bright. Here lies our sun, modest, stable, and alone, orbiting the center once every 230 million years at about 220 kilometers per second. Even at that speed, the journey is slow beyond comprehension. A full galactic year takes longer than all recorded human history many times over. If you could watch the Milky Way from far above, you'd see a glowing pinwheel, gently turning through the dark. At the core, a soft amber light, billions of old stars crowded together. Further out, the spiral arms, blue with youth, shimmering with gas clouds and new suns. Around it all, the halo, pale, faint, and ancient. That is the shape of home. But shapes in the universe are not drawn with edges, they blur. Beyond the disk, faint streams of stars stretch outward, remnants of smaller galaxies once consumed by ours. The Milky Way is a collector of histories, its outer regions stitched together from the remains of others. Every captured star adds a verse to the song of our galaxy's long, patient evolution. We can trace these mergers through motion. In 2018, the Gaia Space Observatory mapped the positions and velocities of more than 1 billion stars. Hidden within that map, astronomers found evidence of one great collision, an ancient dwarf galaxy, now called Gaia Enceladus, that merged with ours about 10 billion years ago. Half the halo's stars may be its remnants. The Milky Way, serene as it seems tonight, is built on long-ago encounters. And yet, from here, beneath a calm night sky, none of that turmoil is visible. All we see is harmony, a delicate arch of light that holds everything in balance. Every flicker is a story older than civilization itself. If you look toward the constellation Sagittarius on a moonless night, you're gazing toward the galactic center. Through the haze of dust and gas, that's where the spiral's heart lies. If you look the other way, toward Cassiopeia or Perseus, you peer outward along the arm that carries us. Either way, you are looking through thousands of light years of stars. For ancient observers, the Milky Way was a path for souls, a bridge of light. To the Greeks, it was milk spilled from the breast of a goddess. To the Chinese, it was the silver river separating lovers in the sky. To the Maya, a great celestial tree whose branches carried the spirits of the departed. No matter the name, every culture looked up and found meaning in that faint band, a reminder that we are part of something vast and quietly connected. The shape of the Milky Way tells us that order can exist within chaos. That gravity, invisible yet constant, can turn dust into beauty, and that even in the enormity of space, there is rhythm. A slow turning, an endless circling, a cosmic heartbeat that continues long after we rest. As our planet turns beneath that immense wheel, the stars above shift almost imperceptibly. Their dance is so slow that a human life cannot see it unfold, yet it happens, always. Stars drift, arms twist, clusters migrate. Everything moves, but so gently that the universe seems still. Perhaps that is why it soothes us, because even in its vastness, it feels calm. It reminds us that motion does not always mean hurry. That change can be quiet. That the most magnificent structures can form from patience alone. And so, as you listen, let that image settle. A spiral of light, floating in darkness, slow and steady as breath. A home made not of walls, but of gravity and time. The Milky Way, our silent companion through the ages. Soon, we'll drift closer to its heart, where gravity gathers light into orbits so tight they defy imagination. But for now, we linger here, in the middle distance. Among calm suns, between the arms. In the quiet part of a grand design. The shape of home. Chapter 2. The Heart of the Galaxy. Deep within the Milky Way, past the lanes of calm stars and drifting dust, lies a region where gravity grows thick enough to bend the path of time itself. Here, light struggles. It slows, it swirls, it yields. This is the galactic center, a dense golden sphere of ancient suns, veiled by clouds of soot and gas, hidden from human eyes for millennia. For centuries, it was a mystery. The naked sky showed nothing unusual in that direction, only a dim, hazy patch behind Sagittarius. But in 1932, faint radio waves began whispering from that place. Decades later, infrared eyes pierced the dust and revealed a compact cluster of stars racing in tight circles around something unseen. Their paths curved too sharply for any visible mass to explain. At the focus of their orbits was an invisible point, holding the weight of 4 million suns. Astronomers named it Sagittarius A star, the quiet heart of our galaxy. It does not shine. It does not roar like the black holes that power distant quasars. It hums softly, radiating only a weak flicker of radio and X-ray light. A sleeping giant, feeding in whispers. Yet sometimes, it stirs. Hot gas spirals inward, glowing brighter as friction squeezes it to tens of millions of degrees. For a few minutes, the core brightens, then fades again. Each flare is a heartbeat, proof that the engine within still breathes. Around it, within just a few light years, lies the nuclear star cluster. A swarm of 1 million suns packed into a space smaller than the distance between us and the nearest star. They move at hundreds of kilometers per second, tracing luminous streaks through the infrared sky. Some are blue-white giants only a few million years old, impossibly young for such a harsh neighborhood. Astronomers call it the paradox of youth. How can tender stars survive beside a monster whose tides could tear them apart? The answer may lie in a ring of gas that once circled close to the black hole. Compressed by gravity and heat, it collapsed before the tides could destroy it, kindling a brief storm of creation. Those stars were born there, children of chaos, racing around the very thing that could unmake them. Within the central few hundred light-years stretches a region called the Central Molecular Zone. It is thick with dust and chemistry, a place where temperatures, pressures, and magnetic fields weave molecules unknown anywhere else. Spectra taken from this zone show traces of alcohols, formaldehyde, and even simple sugars. It is a harsh nursery, yet filled with the ingredients of life. In this furnace of radiation, molecules link and break and link again, leaving a trail of chemical memory drifting through the dark. Towering over it all are long, thread-like magnetic filaments, each dozens of light-years tall but scarcely a light-year wide. They glow faintly in radiolight, vertical streaks crossing the galactic plane like harp strings. No one is certain how they form, perhaps shocks in the magnetic field, perhaps relics of past outbursts from the core. They quiver in the interstellar wind, silent proof that the center of the Milky Way is not only massive but wired, charged, and alive with invisible force. Just beyond these filaments, orbiting farther out, lies a belt of dense molecular clouds. This ring, roughly 15,000 light-years from the center, is sometimes called the molecular ring. Gas streams inward along the galaxy's bar, slows at this radius, and piles up, forming a continuous circle of star-forming regions. It is the galaxy's slow conveyor belt. Gas drifts in, turns to stars, and the leftovers drift further toward the heart. From time to time, Sagittarius A star wakes in earnest. We know this not from direct sight, but from echoes. X-rays reflecting off distant clouds tell us that a few centuries ago the black hole shone thousands of times brighter than today. The light it released then is still bouncing around the inner galaxy, illuminating clouds in sequence like lanterns in fog. Each glow is a delayed memory, proof that calm can hide a fierce past. And beyond even that past lie traces of something grander. In 2010, gamma-ray telescopes discovered two vast bubbles of high-energy radiation rising from the galactic center, stretching 50,000 light-years above and below the plane. They are now known as the Fermi bubbles, enormous ghostly lobes filled with hot plasma and cosmic rays. Their edges are sharp, their interiors faintly glowing. They may be the scars of an ancient eruption, when the black hole flared like a miniature quasar, expelling matter far into the halo before falling silent again. The scale is almost beyond comprehension. Each bubble is larger than the galaxy's disk is thick. They expand at hundreds of kilometers per second, yet in our timescale they appear still. Astronomers estimate they are a few million years old, new by galactic standards. Imagine that, while early humans were shaping stone, the heart of our galaxy was exhaling light into the void. We live beneath the remnants of that breath. Closer to the core, gravity creates its own architecture. Star clusters orbit in families, following elongated loops called X1 and X2 orbits, shaped by the galactic bar's pull. Gas streams along these tracks, colliding and forming shocks where the paths intersect. Those collisions compress the gas, giving rise to dense clouds that may become the next wave of stars near the center. One such cloud is known as the brick, a massive, silent block of dust and hydrogen. It is large enough to form tens of thousands of stars, yet for now it slumbers, cold and dark. Astronomers think tidal forces are squeezing it tighter as it drifts along its orbit. Soon, perhaps in a few 100,000 years, it will ignite, flooding the region with newborn suns. In galactic time, that is the blink of an eye. All around, supernova remnants, shells of gas from exploded stars, lace the inner galaxy like smoke rings. Their shock waves ripple through the dense medium, stirring magnetism, sculpting arcs and cavities. Some of the most luminous clusters, such as the arches and the quintuplet, sit close to the center. Each contains tens of thousands of massive stars, their winds carving tunnels through the surrounding gas. In infrared, they resemble embers floating in gold dust. These massive stars live fast. Within a few million years they will end their lives as supernovae, feeding the black hole with their ashes and renewing the cycle. Death and birth here are neighbors, separated only by light years. Because dust hides visible light, astronomers map this region with radio, infrared, and X-ray telescopes. Together they create a layered portrait: cool clouds in radio, warmer dust in infrared, and violent flares in X-rays. When stacked, these layers reveal a structure that looks almost alive. Filaments, arcs, and streams all converging toward the dark heart at the center. The entire galactic nucleus spans only a few hundred light-years, yet it governs the rhythm of everything beyond. Its gravity sculpts orbits far into the disk. Its outflows enrich the halo. Its moods, quiet or eruptive, set the tone for the Milky Way's long-term evolution. To picture its density, imagine compressing every star you can see in the night sky into a sphere smaller than the distance from Earth to the nearest bright star, Sirius. That is roughly what exists at the galaxy's core. And yet, in that crowding, orbits remain precise, clock-like, beautiful. The heart of the Milky Way is not chaos. It is choreography, complex, ancient, self-sustaining. Each orbit, each flare, each echo of radiation is a step in a dance that has been repeating for billions of years. If one could stand safely near the edge of that region and look inward, the view would be surreal. Stars would race like fireflies trapped in amber light. Dust would glow copper and crimson. The black hole itself would not be visible, only a darkness where light curves and vanishes. Everywhere else, motion would slow into stillness, time thickening as gravity deepened. In May 2022, astronomers using the Event Horizon Telescope released the first direct image of Sagittarius A star. It showed a blurred ring of radio emission surrounding a small shadow, the imprint of space-time itself, curved by gravity beyond escape. That picture, faint and grainy, was the culmination of decades of patient coordination across continents. It confirmed what mathematics had whispered for a century, that at the center of our galaxy sits a point where the known laws of physics fold inward. And yet, for all its power, this heart is quiet. It consumes slowly. It governs gently. Without it, the Milky Way's symmetry would unravel, its stars drifting into the void. With it, everything holds together, balanced between falling and flying apart. When the galaxy was young, that balance was louder. The black hole fed more often, igniting the Fermi bubbles and the winds that enriched the halo with heavy elements. Now, in middle age, it rests. Perhaps in another epoch, a tide of gas will reach it again, and it will awaken, shining across half the sky. For now, it sleeps, a guardian in the dark. Astronomers sometimes call our galaxy a barred spiral, but beneath that label lies something more poetic. The bar funnels matter to the heart. The heart breathes it out in light and wind. The arms carry it away. Over billions of years, this slow circulation keeps the Milky Way alive. A cosmic heartbeat, steady and enduring. And so the heart of the galaxy beats, not in seconds, but in ages. Each pulse is a flare. Each breath is a bubble rising through space. Between those moments, quiet reigns. A silence wide enough for whole civilizations to rise and vanish before the next flicker comes. When you look toward Sagittarius on a clear night, remember, behind that pale patch of sky lies a region so crowded that stars are measured in hours of light travel, not years. A place where gravity is thick as honey, where light itself curves in surrender, and where, despite the chaos, everything moves in rhythm. It is the center that holds the dark, glowing heart of the Milky Way. Our galaxy's pulse, too slow for ears, too vast for eyes. But steady, always steady, beneath the quiet surface of the night. Chapter 3, The Sea of Stars. Across the great disk of the Milky Way, the spiral arms unfurl like slow waves on a black ocean. Each arm glows with countless suns, new, bright, short-lived things, born from clouds that stretch hundreds of light-years wide. They shimmer, then fade, replaced by the next generation in a cycle older than any planet that orbits within. If we could drift above our galaxy and look down, we would see it breathing. Gas gathers, stars ignite, winds rise, and the dust begins to flow outward again. Everywhere, creation and surrender balance each other in perfect rhythm. The spiral arms are not solid structures. They are moving patterns, density waves, gentle traffic jams made of stars and gas. As a wave passes through, it squeezes the gas ever so slightly, pushing clouds to collapse. Inside those clouds, gravity takes over. Atoms that once drifted in silence begin to fall together. The fall quickens. Friction warms the center. And from that warmth, a new sun is born. We call these clouds giant molecular clouds. The smallest stretch for tens of light years, the largest are hundreds across. Each one holds the mass of 1,000,000 suns, but the material is thin. If you could scoop it into your hands, it would be more vacuum than air. Yet given time, gravity gathers that faintness into fire. Inside the arms, these clouds tangle and collide. Some form open clusters, loose families of a few thousand stars. Others give rise to enormous nurseries, places like the Eagle Nebula, where towering columns of gas, called the Pillars of Creation, stand 5 light-years tall. At their tips, the youngest stars sparkle in ultraviolet light, slowly eroding the clouds that made them. What looks like smoke is really dust, carbon and silicate grains smaller than flour, floating through incandescent hydrogen. Elsewhere, in the Orion Nebula, just 1,350 light-years away, the same story unfolds on a smaller stage. There, for massive stars at the center, the trapezium, flood the region with radiation so intense it carves cavities into the gas. Around them, hundreds of newborn suns glimmer through the haze, each still wrapped in a faint, spinning disk. Those disks are planetary seeds, rings of dust and ice that will, over millions of years, grow into worlds. Our own solar system began inside such a nursery. Long before Earth had oceans, before the sun had planets, a cloud much like Orion's collapsed and warmed. At its heart, a single star kindled. Around it, a disk coalesced. That disk cooled, condensed, and began to build everything we know. In the quiet arms of the Milky Way, that same process repeats endlessly. Every second, somewhere, a new star ignites. Every second, somewhere else, another fades and dies. The galaxy's glow is the balance between those two acts. Astronomers trace this cycle by studying light. Newborn stars shine blue and hot, older ones glow red and calm. When telescopes map the arms in color, blue patches mark regions alive with youth. In between lie the aged neighborhoods, where the fires have cooled. The arms are therefore both nurseries and graveyards, depending on how you look. The gases that form stars are mostly hydrogen and helium, the simplest elements. But inside each star, nuclear fusion forges heavier ones: carbon, oxygen, silicon, iron. When massive stars explode, they scatter those elements back into space, enriching the clouds that will follow. Thus, each new generation is a little richer than the last. You and I, and every planet, are part of that slow enrichment. We are, in the truest sense, made of stellar inheritance. Even within the calm rhythm of creation, storms arise. Supernova shock waves travel through the disk at thousands of kilometers per second, compressing new clouds ahead of them. Those blasts trigger new births, connecting one generation to the next in a cosmic chain reaction. Some regions flare with intense starburst activity, thousands of suns forming in just a few million years. Others fall into long silences, their gas dispersed, waiting to gather again. From a distance, the Milky Way's arms resemble brushstrokes of pale light, but each stroke hides unimaginable structure. There are filaments called the bones of the galaxy, needle-thin ridges of cold gas that mark the very spines of the spiral arms. They run straight for hundreds of light years, guiding matter like rails in the dark. Along them, new clusters form at even intervals, like beads strung on invisible wire. Among these structures float clusters of many ages. Open clusters, loose, glittering swarms, are the children of the arms. They wander for a few 100 million years before dissolving into the galactic field. Our sun was likely born in such a cluster, its siblings long since scattered across the disk. Further out lie vast, faint clouds of neutral hydrogen, mapped not by sight but by radio waves at a wavelength of 21 centimeters. Those maps reveal the full spiral outline of the Milky Way, tracing arms we cannot see through dust. From them we learn that our galaxy has 4 major arms and several smaller bridges, each one a current in the sea of stars. Between the bright lanes, dark rifts cut through the glow. These are interstellar dust lanes, cold filaments that absorb starlight. Through binoculars, they appear as black rivers crossing the Milky Way's band. They are not empty. They are rich with carbon, ice, and organic molecules. The same ingredients that, under gentler circumstances, give rise to life. In the far reaches of the arms, the gas thins, but star formation never quite ceases. Astronomers have found young clusters even beyond the edge of the visible disk, proof that the galaxy still grows, adding faint outer rings to its spiral. Each new generation drifts a little farther out, extending the Milky Way's luminous breadth into the dark. The average lifetime of a massive blue star is just a few million years. The lifetime of a small red dwarf can exceed 1 trillion. So when you gaze at a bright blue star, you are seeing something that will vanish long before our sun finishes a single orbit of the galaxy. When you look at the faint red stars that fill the background, you are seeing endurance. Tiny, steady flames that will outlive everything we know. Among the most beautiful phenomena in this sea are reflection nebulae, clouds that do not glow on their own but shine with borrowed light. Blue light from nearby stars scatters off their dust, turning the clouds into soft veils of color. They are cosmic echoes, visible only because light lingers on their surfaces. And then there are emission nebulae, where ultraviolet radiation strips electrons from atoms, causing them to glow from within. These are the bright pink and crimson regions captured by telescopes, the raw, living skin of the galaxy. Every atom of hydrogen, every grain of dust, participates in this endless ebb and flow. The Milky Way is not a static picture, it is a fluid body. Its arms twist slowly, each rotation taking hundreds of millions of years, yet inside them stars flare and fade in moments. The contrast between motion and stillness, between age and youth, is what makes it so profoundly calming to imagine. If we could translate its light into sound, the galaxy would hum in low, continuous tones. The youngest stars would ring brightest, the old giants would pulse slowly, and the whole spiral would throb like a heartbeat measured in millennia. Far above the plane of the disk, the glow dims, but it does not vanish. Hot gas and cosmic rays leak upward, forming faint chimneys that connect the arms to the halo. Through those channels, the Milky Way breathes, releasing energy, taking in new material from intergalactic space, sustaining itself across eons. Our sun, for all its steadiness, participates in this grand migration. As it orbits the center, it drifts gently in and out of the spiral arms. Every few 100 million years it passes through a crowded region of star birth, then moves into a quieter lane. Each crossing reshapes the conditions around it, perhaps influencing comets, climates, and the subtle rhythms of life on Earth. From the vantage of deep space, all of this unfolds in silence. There are no borders, no clear beginnings or endings, only gradients of light. One cloud fades, another brightens, and the pattern goes on. To the human eye, the Milky Way seems serene. To the instruments that measure its energy, it is alive with motion. Winds, flares, magnetic fields twisting like invisible ribbons. Yet even these forces obey harmony. Each burst of radiation cools into calm, each collision spreads into peace. The arms cradle everything from blazing supergiants to solitary embers smaller than Jupiter. Between them drift brown dwarfs, objects too small to ignite but too massive to be called planets. They glow faintly in infrared, tiny sparks adrift in the current. Scattered throughout the disk are countless stellar remnants, white dwarfs, neutron stars, and black holes. They mark where once there was light, now compressed into silence. Their gravity sculpts nearby gas, steering it into streams that feed the next generation of stars. Even death, here, serves creation. In the grand balance of the galaxy, nothing is truly lost. Matter shifts states, light changes form, energy moves but does not vanish. The Milky Way endures by transforming itself, again and again, softly, endlessly. If one could ride a beam of light through an arm of the galaxy, the scenery would pass like slow weather. A luminous nebula fading to dark dust, a cluster of newborn stars, then open space mottled with distant glimmers. It would be both vast and delicate, like crossing a sea whose waves move slower than thought. That is why astronomers sometimes describe the disk as a living ocean. Its currents are gravitational, its tides are measured in millions of years, and its inhabitants, stars, are bright islands that rise and sink with time. When seen this way, the Milky Way becomes less a place and more a process. It is the continuous act of stars forming, shining, and returning their light to the dark. Every photon that reaches our eyes tonight began in that process. Born in the core of some distant sun, wandering across space, and finally arriving here, to remind us that the galaxy is still moving, still making, still glowing. As we drift deeper into the sea of stars, remember that the calm above your roof is connected to that grand ocean. The faint glow crossing the night sky is not decoration, it is evidence. It is proof that even in vastness, beauty endures through repetition, through rhythm, through patience. Somewhere, a star forms. Somewhere else, one fades. And the Milky Way, like the tide, continues to rise and fall in silence. The sea of stars never sleeps. It only changes its tempo, slower than a dream, longer than a life, steady as breath in the lungs of the universe. Chapter 4: The Halo Above Us, above the glowing spiral of our galaxy, beyond the lanes of starlight and dust, lies a realm that few ever picture. A vast, invisible sphere that surrounds the Milky Way like a veil of breath. It is called the halo, a quiet region where time stretches and density thins, where ancient stars drift without hurry. If the galactic disk is the living ocean, the halo is the still air above it, wide, faint, and almost transparent. From the ground, you cannot see it. There is no edge or color, no bright rim announcing its boundary. And yet, without it, the galaxy would be incomplete. The halo extends far beyond the last visible star of the spiral arms. A nearly spherical region reaching more than 300,000 light-years from the center. Inside it lie relics of our galaxy's earliest days. Old stars, dark matter, faint clusters, and thin streams of debris left behind by galaxies long since devoured. The stars here are ancient, older than most in the disk by billions of years. They carry within their light the signatures of a simpler universe. Their atmospheres hold almost no heavy elements, just hydrogen and helium. A reminder of a time before the galaxy had learned to make anything else. Each halo star is a fossil, glowing faintly from an era when the Milky Way was still forming. When gravity pulled small proto-galaxies together, their orbits tangling into one. Those collisions filled this space with debris, scattered clusters, thin streams, and solitary stars that now roam the halo like sparks adrift on a slow wind. Many of those streams still trace the paths of their long-vanished parents. The Sagittarius stream winds almost entirely around the sky. A ribbon of stars stretched from a dwarf galaxy that passed too close to us and was torn apart. Its remnants, what's left of that galaxy's core, still orbit our own, wrapped like a ghostly scarf around the Milky Way's shoulders. Another thread, called the GD1 stream, flows across the northern sky. It is thin as a blade of light, just a few hundred light-years wide, but tens of thousands long. By studying its shape, astronomers have learned to feel the invisible. Tiny kinks and gaps along the stream reveal unseen masses, dark clumps drifting through the halo. Each kink may mark where a small cloud of dark matter brushed past, bending the path of the stars without leaving a visible trace. This is how we map what cannot be seen. Dark matter, the mysterious substance that outweighs all visible stars and gas combined, is thought to fill the halo. It forms the unseen skeleton of the Milky Way, its gravity giving the galaxy its shape and holding the outer stars in their orbits. We don't yet know what dark matter is. It does not shine, absorb, or scatter light. It passes through ordinary matter as though it isn't there. And yet, its pull is unmistakable. The outer stars move too fast for visible matter alone to hold them. Something unseen is binding them, something vast and patient. To imagine its presence, think of a glass dome covering the galaxy. A dome so clear that you could not tell it was there until you tried to weigh it. That dome, invisible but massive, is the halo's true body. Its substance surrounds us, penetrates us, passes through us at all times, carrying with it the quiet gravity of the cosmos. Scattered within that invisible sea are the globular clusters, spherical swarms of ancient stars that orbit far from the disk. Some are so old they formed before the Milky Way itself was fully born. Each cluster holds hundreds of thousands of suns packed into a sphere only a few dozen light-years across. In their centers, stars are so dense that the night would never darken. A permanent dawn of golden light in every direction. There are more than 150 known globular clusters orbiting our galaxy. The largest, Omega Centauri, may not be a cluster at all, but the leftover core of a small galaxy our Milky Way once consumed. Its stars span a wide range of ages and compositions, as if it once had its own history before being folded into ours. Beyond these clusters, the halo contains something even fainter. A vast reservoir of hot, thin gas, the circumgalactic medium. It stretches farther than the stars, glowing softly in X-rays. Its temperature, 1,000,000 degrees. Its density, so low that all the atoms in a cubic meter could be counted on one hand. This tenuous plasma fills the space between galaxies, connecting them through filaments that span the cosmic web. When astronomers measure light from distant quasars shining through this halo, they find fingerprints, absorption lines of oxygen, neon, and other ions. Evidence that even the faint outskirts of our galaxy are enriched with elements made in stars. That means the Milky Way breathes. Material from the disk rises in fountains, heated by supernovae, cools in the halo, then slowly drifts back down again. It is a galactic weather system, a circulation of matter from center to edge and back. Sometimes entire galaxies fall into this halo. The Large and Small Magellanic Clouds, two luminous companions visible from the southern hemisphere, are wrapped in a trailing ribbon of hydrogen called the Magellanic Stream. That stream stretches 200,000 light-years. A river of gas drawn out by gravity and pressure as the smaller galaxies orbit the Milky Way. It is slowly feeding our galaxy with new fuel for star formation. A quiet rain from the halo that will one day become new stars in the disk below. The halo is not symmetrical. It ripples, bulges, and carries scars of every encounter the Milky Way has ever had. When the Sagittarius dwarf first plunged through the disk, It sent shock waves through both regions. Ripples in the disk's motion, waves in the halo's shape. These patterns persist for billions of years, slowly unwinding but never entirely fading, like faint rings on water long after the stone has sunk. In some directions, the halo glows faintly in gamma rays. In others, in diffuse X-rays. These energies hint at cosmic rays and hot gas streaming outward from the central regions, filling the halo with light too soft for human eyes to see. What may be most astonishing about the halo is its sheer size. Our sun lies 26,000 light-years from the center, yet the halo reaches more than 10 times farther. If the Milky Way were a coin on a table, the halo would be a bubble larger than a beach ball surrounding it. And inside that bubble, nearly every star you can see in the night sky is huddled near the center. A tiny flicker within a vast, invisible room. Stars in the halo move differently from those in the disk. They follow long, elliptical paths, plunging above and below the galactic plane. Their orbits are slow, graceful arcs that can take billions of years to complete. Some drift so far out that they spend most of their lives in solitude, feeling the faintest tug from the galaxy they still call home. Among these wanderers are stars moving faster than escape velocity. Hypervelocity stars, flung from the galactic center by the black hole's gravity. They race through the halo at thousands of kilometers per second, destined to leave the Milky Way forever, carrying with them traces of its inner secrets. Every so often, a dying star explodes near the boundary of the disk, and its ashes spread upward into the halo, mixing with the ancient gas that has waited there for eons. The light from those events fades, but the metals they release remain. Iron, calcium, magnesium, the ingredients of future planets, scattered like pollen on the cosmic wind. The halo, though vast, is delicate. It is so thin that its atoms rarely collide. Temperatures remain high because energy has nowhere to go. Every photon that escapes carries away a whisper of its existence. A faint glow that X-ray telescopes catch like embers in the dark. Some astronomers describe the halo as the galaxy's memory. It keeps record of everything that has ever fallen in or drifted out. Every merger, every supernova, every wind from the core has left a trace here. A small change in composition, a subtle swirl in motion, a ripple in density. By studying those faint imprints, scientists reconstruct the Milky Way's biography. Written not in light but in absence, a diary of things too quiet to be seen. One day, far in the future, the halo will greet a visitor. The Andromeda Galaxy, our nearest large neighbor, is on a slow collision course with the Milky Way. In about 4 billion years, their halos will touch first. Long before the disks collide, gas and dark matter will mingle. Stars from each system will feel the gravity of the other, and faint streams will begin to flow between them. The merging of halos is the first handshake of galaxies, a silent greeting across millions of light years. When that time comes, new patterns will form. The current halo will expand, reshaping itself into a new, shared envelope around the merged galaxy. But the stars we see tonight, the globular clusters still circling above us, will continue their long orbits, unhurried, serene. From our small world, we cannot feel the halo's touch, but it holds us all the same. Every photon of starlight must cross it before reaching us. Every cosmic ray, every radio wave, every drifting atom travels through that vast, thin sea. It is both barrier and bridge, the calm between our galaxy and the rest of the universe. If we could float at its edge and look back, the Milky Way would appear as a bright coin suspended in endless dark, its arms glowing faintly, its center burning gold. Around it, the halo would shimmer almost imperceptibly, a soft haze of light, so delicate it would vanish if you blinked. That is the quiet crown of our galaxy. The halo above us, ancient, weightless, filled with relics of long-gone stars and the unseen matter that binds it all. It does not move quickly. It does not shine brightly, but it holds everything together. Patiently, invisibly, beautifully, the silent boundary between home and forever. Chapter 5. The River of Time. The Milky Way moves not in haste, but in an ancient, deliberate rhythm. Everything within it drifts, glides, and turns, bound by gravity's unseen current. If you could watch the galaxy from afar, you would see no stillness, only the slow turning of a luminous tide. Our sun, that bright and constant companion, is not anchored where it shines. It sails through space, carried by the galactic current like a leaf upon an invisible river. Around the center it moves, and has been moving since long before the first life stirred on Earth. Astronomers call that path a galactic orbit. One full circle takes about 230 million years. A single lap around the Milky Way's heart. That means since Earth was born, the Sun has made only 20 orbits. All of human history occupies less than a blink along its track. When the dinosaurs walked the planet, the Sun was on the opposite side of the galaxy. When the first forests formed, it was nearer to the heart. Now, in this brief human age, we are halfway through our 21st journey, sailing quietly through one of the calmer lanes of the disk. The Sun travels at 220 kilometers per second, fast enough to cross the distance from New York to Los Angeles in less than 20 seconds. And yet, in the vastness of the galaxy, that speed feels like stillness. All the nearby stars move in the same direction, each on its own slow curve around the center. Together, they create the illusion of a static sky. But the illusion fades when time is allowed to flow. If we could watch a time-lapse spanning millions of years, the constellations would twist and scatter, their familiar shapes dissolving into new patterns. The Big Dipper would spill, Orion's belt would drift apart, and the sky would change its face completely. The Sun's orbit is not a perfect circle. It stretches slightly, an ellipse that carries us nearer to the galactic center and then away again. Each approach takes millions of years. Each retreat, another few million. The journey is so slow that even civilizations would rise and fall before a measurable change could be seen. And the Sun does not travel alone. It carries with it an entire entourage. Planets, moons, comets, asteroids, each bound to it by gravity, each following the same grand motion around the galaxy's core. The entire solar system is like a boat, with the planets spinning like wheels as it sails downstream. We drift through a region known as the local arm, a minor spiral spur between two great lanes. Our neighborhood contains thousands of stars, bright blue giants, dim red dwarfs, and the scattered embers of older suns. Together they form a community of motion, all flowing in the same broad direction, like raindrops sliding down a windowpane. As the sun moves, it also bobs gently up and down through the galactic plane. Every 30 to 35 million years, it crosses the midline, climbing above and dipping below the disk. This slow oscillation is like breathing. Some scientists call it the galaxy's heartbeat, a rhythm that influences not only stars, but perhaps even life on Earth. When the sun passes through denser regions of the disk, gravitational tides may disturb the distant Oort cloud, that vast sphere of icy bodies far beyond Pluto. Some of those comets are nudged inward, falling toward the inner solar system, occasionally crossing Earth's path. Each crossing of the galactic plane may therefore send a faint shower of comets our way, a cosmic echo of our motion through the stars. The Milky Way itself turns far faster at its center than at its edge. This difference in speed is what gives it shape, a rotation curve governed by both visible stars and unseen dark matter. Stars near the core complete an orbit in just a few tens of millions of years. Out here, we take 10 times longer. It is a vast differential. And yet, the galaxy holds together perfectly, each part moving in quiet harmony with the rest. Our star's current position is roughly 26,000 light-years from the center, in a stable and gentle orbit. It sits far enough away to be safe from the violent tides of the inner regions, yet close enough that we still feel the warmth of its gravitational embrace. It is, by cosmic standards, the perfect distance for peace. Every orbit the sun makes is slightly different from the last. Encounters with passing stars, clouds of gas, and the slow tug of the galaxy's spiral arms all shift our path by small amounts. Over billions of years, these shifts add up. The sun may have formed closer to the center, then gradually migrated outward to its present home. It is possible that Earth owes its mild climate and long stability to this gentle migration away from the crowded core. To measure these motions, astronomers use the light of nearby stars. As stars move toward us, their light shifts slightly bluer. As they move away, it reddens. This Doppler effect reveals their speed and direction, allowing scientists to build vast maps of motion across the Milky Way. From these maps, we learn that the galaxy's rotation is smooth, its rhythm constant, its structure held by invisible hands. The sun's galactic orbit defines a unit of time so immense that it humbles every calendar we have ever made. We call that span a galactic year. It is not marked by seasons or equinoxes, but by the slow drift of everything we know, around a single unseen point in the night sky. When the first mammals appeared, one galactic year had not yet passed since the dinosaurs began to roam. When the first humans looked up, only a fraction of one had elapsed since Earth cooled from its fiery youth. And when this current orbit ends, hundreds of millions of years from now, the continents will have shifted beyond recognition. The sky will host new constellations, and perhaps a different species will gaze upward, wondering what lies at the heart of that pale river of light. In this way, our orbit binds us not just to space, but to time itself. Each revolution of the sun is a turning of the galactic clock. Every tick lasts longer than all of recorded history. The Milky Way does not stand still, either. While the sun circles the center, the entire galaxy drifts through the universe at nearly 2 million kilometers per hour. We, the disk, the halo, the heart, all of it, are moving together toward a region of space known as the Virgo cluster, drawn by the combined gravity of thousands of galaxies. Even the cluster itself moves, pulled by greater structures beyond, flowing along filaments of dark matter that span the cosmos. To the universe, motion is eternal. To us, it is imperceptible. We sit upon a planet that spins once a day, circles the sun once a year, rides the sun around the Milky Way once every 230 million years. And yet, in the stillness of a quiet night, we feel none of it. Perhaps that is why the night sky soothes, because though everything is in motion, the patterns above seem fixed. We find comfort in that illusion, the idea that there are constants amid change. But the truth is gentler, not harsher. The constancy we see is a consequence of grace. Every star moves in harmony with the rest. So the great pattern persists even as each point shifts. It is balance, not stasis, that creates calm. Over billions of years, the Milky Way's rotation has shaped the lives of its stars. Gas clouds compress, spiral inward, and then drift back out. Clusters are born, age, and disperse. Spiral arms twist and unwind. Even the galaxy's central bar turns slowly within the disk, its rhythm dictating the motion of everything else. To exist inside this machine is to participate in time itself. Astronomers sometimes say that galaxies are clocks made of stars. Each orbit, each rotation, each pulse of light is a measure of duration. If so, then the Milky Way is the most patient clock ever built. One whose hands move so slowly that a second lasts 1,000,000 years, and whose chime is the faint hiss of starlight reaching us across space. Our solar system rides within one of the spiral arms, but it also drifts relative to its neighbors. Over tens of millions of years, we pass from one arm to another, sometimes moving through rich regions of star formation, sometimes through quiet expanses between. This slow wandering ensures that no single view of the night sky lasts forever. If humanity could endure for geological time, future generations would look up and see a sky unrecognizable to us. New constellations, new stars, perhaps even the faint glow of a different spiral arm nearby. And yet, the same Milky Way would cradle them. The same rhythm, the same grand turning, the same river of time flowing beneath their existence. Every motion we make, every thought and dream, rides upon that current. When we speak of now, we are really naming a single droplet within that vast flow. Behind us stretch billions of years, ahead, billions more, and all of it moves with quiet precision, as if the universe itself keeps time by the Milky Way's slow spin. In a sense, it does. The rotation of galaxies defines the rhythm of cosmic evolution. Through that motion, matter collects, forms stars, builds planets, and creates the conditions for life. Without that turning, there would be no cycle, no mixing, no renewal. The river of time is what allows the cosmos to breathe. And so, as our sun glides along its ancient path, the planets follow, the comets drift, and all the while the galaxy continues its silent dance. There is no pause, no rush, no beginning, no end. Only motion, continuous and calm. If we could step outside the Milky Way and watch it for an eon, we would see the spiral rotate like a slow wheel of light. Its arms drifting, its heart pulsing faintly. We would see our sun as a small dot, making its endless journey around the center. Not hurrying, not resting, just moving with the river, as it always has. To live on Earth is to be part of that motion. Every heartbeat, every breath, every moment of stillness is carried along by the galaxy's turn. Even as we sleep, we are traveling through space, through time, through the quiet rhythm of a galaxy that never stops. The Milky Way is the clock, and we are its seconds, small, fleeting, luminous, moving ever onward, through the river of time. Chapter 6. Collisions and Companions. Far beyond the spiral arms of the Milky Way, faint lights drift in the dark. Companions, small and distant, bound by gravity's soft tether. They orbit quietly, following ancient paths through the void. Each one tells a story of origin, of gathering, of return. Though we see our galaxy as a grand, solitary spiral, it is not alone. We live within a small family of galaxies called the local group, a cluster of more than 50 members, each one moving through space in a slow, collective dance. At the center of this family are two great spirals, the Milky Way and the Andromeda Galaxy. Between them stretches nearly 2.5 million light-years of space, a gulf so wide that even light, the fastest thing in existence, takes more than 2 million years to cross it. And yet, despite that distance, they are already entwined. Gravity has linked them in a slow embrace, drawing them together across the ages. Every second, Andromeda moves closer, at about 110 kilometers per second, so gently that the human eye will never perceive the change. But given time, that slow drift will culminate in an event of staggering beauty. In roughly 4 billion years, the two galaxies will meet, not in a violent collision as we might imagine, but in a graceful merging of stars and light. Because stars are so far apart, they will rarely touch. Instead, the galaxies will pass through each other, their shapes warping, their arms stretching into long tidal streams. Gravity will draw bridges of stars between them, arcs that shimmer like ribbons across the night. The first encounter will last hundreds of millions of years. They will drift apart again, then fall together once more. Over time, their orbits will decay, and after 2 or 3 such passages, they will finally merge, becoming a single, larger galaxy, an elliptical island of light. Astronomers call this future world Milkdromeda, a serene blending of two spirals into one. Its new heart will host the paired supermassive black holes of both galaxies, slowly spiraling together, releasing waves that ripple through the fabric of spacetime itself. When the last wave fades, only one quiet core will remain, twice as massive, twice as calm. To the beings who might live in that distant future, the night sky will look utterly different. The graceful band of the Milky Way will be gone. Instead, a vast oval of stars will fill the heavens, so bright that it may outshine the moon. Yet the universe will be the same, its laws unchanged, its motion just as patient as it is now. Our galaxy has been through such meetings before. Its outer halo is filled with traces of smaller companions that once fell in and vanished. Streams of stars arc through the darkness, remnants of long-consumed dwarfs that surrendered their light to the greater whole. One of the most remarkable is the Sagittarius dwarf galaxy. It circles the Milky Way on a tilted path, plunging through the disk like a skipping stone on water. Each passage strips away more of its stars, stretching them into the Sagittarius stream, a faint river of light that wraps around the galaxy in multiple loops. Even now, it continues to dissolve, its remaining core trailing dust and stars behind it. This is how galaxies grow. Not by conquest, but by quiet assimilation, by gathering their smaller neighbors into themselves, weaving their histories into one. Another faint companion, the Canis Major dwarf, lies so close and so dim that it remained hidden until this century. Its stars, slightly redder and poorer in metals than ours, hint at a different beginning, a separate world that the Milky Way has slowly drawn apart. Tidal forces stretch it thin, and its stars now mingle with ours, their orbits nearly indistinguishable from the outer disk. The Milky Way has dozens of satellite galaxies. Some, like the large and small Magellanic Clouds, are bright enough to see with the naked eye from southern latitudes. Others are faint wisps, known only through careful counts of their stars. All are held by our galaxy's gravity, each following an orbit shaped by dark matter and time. The Magellanic Clouds are irregular in form, chaotic, asymmetrical, and richly alive with star formation. The large cloud, about 160,000 light-years away, is home to the Tarantula Nebula, a stellar nursery so massive that it glows brighter than any in our own galaxy. Inside it, young clusters shine blue-white, their radiation sculpting pillars and arcs of gas. As these two clouds orbit each other and the Milky Way, they leave behind trails of hydrogen gas, the Magellanic Stream and its lesser twin, the leading arm. Together, they wrap around our galaxy like twin ribbons, feeding it with fresh material that will one day fall into the disk and ignite new generations of stars. Each satellite moves in a complex rhythm. Some are slowly spiraling inward, their orbits decaying as they lose energy to gravitational tides. Others may yet escape, flung into intergalactic space by the very forces that bind them now. Their paths trace invisible lines across the halo, the choreography of a family that has been together for billions of years. The local group itself is just one small part of a greater structure. Beyond it lies the local sheet, a flattened layer of galaxies stretching tens of millions of light-years across. And beyond that, the Virgo supercluster, a loose gathering of thousands of galaxies drifting toward one another. On those scales, gravity works slowly, but inexorably. The universe, though expanding, still allows its children to find each other. Our galaxy's companions come in many forms. There are dwarf spheroidals, like Draco and Sculptor, ghostly clouds of old stars with almost no gas or dust. There are ultra-faint dwarfs, discovered only recently, each containing just a few thousand suns. Tiny satellites that are more dark matter than light. And there are dwarf irregulars, shapeless and turbulent, their gas still churning with new star formation. Each one contributes to the Milky Way's evolution. When they fall in, they stir the disk, triggering waves and ripples that travel through its stars. Some of the subtle bends we see in the Milky Way's outer regions may be the lingering echoes of those encounters, like ripples spreading across a pond long after the pebble has sunk. Even now, the Sagittarius dwarf's repeated plunges may be reshaping our galaxy. Data from the Gaia mission shows that the disk carries faint oscillations, waves that ripple outward in patterns matching its last crossing. It is possible that our sun itself rides one of those ripples, moving slightly up and down as the wave passes beneath us. A quiet reminder that even in stillness, the galaxy remembers every touch. In the coming billions of years, these smaller companions will continue to merge and fade, their light absorbed into the Milky Way's glow. And then, when Andromeda finally arrives, a new chapter will begin. Andromeda, or M31, is larger than the Milky Way by nearly a third. It, too, has a retinue of satellites, and its own central black hole, 10 times the mass of ours. Its spiral arms gleam with star clusters and nebulae, its outer disk threaded with dust. From Earth, it appears as a faint, elongated smudge in the constellation Andromeda, visible even without a telescope. The farthest thing most people will ever see with their own eyes. Despite the inevitability of their collision, the encounter will not bring destruction. Space between stars is vast. Two suns could pass within 1 million kilometers of each other, a cosmic near miss, and never collide. Instead, the galaxies will blend gracefully, their stars finding new orbits within the merged halo. Some systems will be flung into intergalactic space. Others will settle into the calm of the new center. For a brief span, perhaps a few 100 million years, the sky over Earth, if it still exists, will be filled with arcs of light. The Milky Way will stretch, twist, and then bloom into a double spiral, its arms interlocking with Andromeda's in a luminous dance. It will be one of the grandest sights the universe can offer, yet silent, too slow for any creature to witness in its entirety. Long after that union, when the black holes have merged, and the new galaxy has settled, star formation will gradually wane. The gas that once formed spirals will thin and fade. The newborn Milky Way will become a smooth, glowing ellipse. A calm, red galaxy adrift in deep time. But even then, the story will not be over. Tiny dwarfs will continue to orbit its edges. Fresh matter will fall in from the cosmic web. And new stars will still flicker into being in hidden corners. The rhythm will simply slow. The music will quiet. But the dance will never truly end. For now, we live in the midst of that motion. A single point within the Milky Way's slow approach to Andromeda. If you could look up in ultraviolet light, you would see faint bridges of gas already connecting the two galaxies. Their halos have begun to overlap, trading whispers of matter long before the first visible meeting. That is how the universe connects its pieces, not with sudden impacts, but with gentle attraction, long before the participants even touch. Our galaxy's companions, the dwarfs, the clouds, the streams, are part of that same quiet network. They feed, shape, and guide the Milky Way, ensuring that nothing in the universe ever stands alone. In the darkness between galaxies, gravity keeps time. It draws paths across space, tangles them, releases them, and in doing so, sculpts the large-scale beauty we see today. The Milky Way and Andromeda are destined to merge. But in truth, that destiny has already begun. Their halos have met. Their orbits have synchronized. The first threads of the future galaxy are already weaving themselves in silence. It is the universe's way of reminding us that connection is inevitable. No system exists forever apart. Everything drifts toward union, slowly, peacefully, gracefully, as if time itself desires companionship. Chapter 7: Ancient Lights. Long before the Milky Way had arms, before its disk began to spin, there was only darkness scattered with the first sparks of creation. Those earliest stars, born from pure hydrogen and helium, lit the young universe more than 13 billion years ago. They lived quickly, died violently, and left behind the seeds of everything that followed. When the debris of those first explosions drifted and cooled, gravity gathered it once more, this time into the shape that would become our galaxy. The relics of that ancient age still exist, not in the crowded disk we see tonight, but in the quiet outskirts and deep core, where time moves differently and memory endures. They are called population 2 stars, ancient suns that formed before the Milky Way settled into its spiral. Their light is steady but faint, their chemistry simple, lacking the heavier elements forged by later generations. Each one is a message from a universe still learning to make complexity. Astronomers search for these elders in the halo and bulge. Their metallicity, the measure of heavy elements, tells the story of when they were born. Some contain less than 1,000th the iron of our Sun. Their atmospheres almost untouched by prior generations of supernovae. These are the true ancients, the survivors of the galaxy's childhood. Among them are faint red subdwarfs that will burn for trillions of years, outliving every other kind of star. They shine with quiet persistence, Their light so dim that entire clusters can hide unseen until the right telescope finds them. One such cluster, M92 in Hercules, is thought to be nearly as old as the Milky Way itself, about 13 billion years. Its stars orbit together in a tight sphere, their motion so slow that a single circuit around the center takes hundreds of millions of years. To look upon M92 through a telescope is to peer directly into the dawn of our galaxy. Another cluster, NGC 6397 in Era, lies only 7,800 light-years away and glows with the faint orange of age. Every star within it has been shining since before Earth existed. Inside such clusters, space is crowded. If you lived on a planet there, your night sky would hold thousands of suns, each bright enough to cast its own shadow. Farther out in the halo drift solitary elders, stars that may once belonged to smaller galaxies consumed by ours. Their elongated, plunging orbits mark them as immigrants, foreign travelers adopted by the Milky Way's gravity. They carry distinct chemical fingerprints, clues to the galaxies that birthed them billions of years ago. One of the most studied is HE 1523-0901, a faint star in Sagittarius whose light carries traces of thorium and uranium. By measuring the decay of those elements, astronomers can estimate its age, about 13.2 billion years. It has been burning quietly since the universe was young, a living clock, older than the Milky Way's current form. Even older evidence hides within white dwarfs, the dense remains of ancient stars that have exhausted their fuel. Some are so cool that they no longer glow in visible light, emitting only faint infrared heat. They are stellar embers, the fossils of suns that once blazed before our planet formed. In the galactic bulge, the swollen central region filled with golden light, astronomers find a mix of ages. Some stars there are younger, but woven among them are the true ancients. Their motions chaotic, their orbits crossing in all directions. They were formed before the bar, before the spiral, when the Milky Way was a formless cloud collapsing under its own weight. Within that crowd are RR Lyrae variables, pulsing stars that expand and contract in a steady rhythm. Because their brightness follows a predictable pattern, they serve as cosmic mile markers. By mapping their distances, scientists traced the early shape of the Milky Way, revealing that even its oldest skeleton had order. The oldest globular clusters hold clues to how galaxies first assembled. Some may be survivors of small proto-galaxies that merged to build ours. Their stars orbit differently from those in the disk, suggesting separate origins now folded into one system. Every cluster is a relic, a miniature galaxy preserved within the larger whole. Among the most intriguing is Omega Centauri. To the naked eye it looks like a fuzzy star in the southern sky, but through telescopes it reveals millions of suns packed together. Unlike typical clusters, its stars show a wide range of ages and metallicities, signs that it once was the core of an independent dwarf galaxy. The Milky Way captured it eons ago, stripping away its outer layers and leaving only this glittering heart, Chemical analysis of ancient stars tells us not only when they formed, but also what kind of explosions enriched their birth clouds. Some halo stars contain heavy elements, gold, platinum, europium, produced in rare cosmic events such as neutron star mergers. Others show patterns that match the yields of the first massive supernovae. Each elemental ratio is a line in the diary of early cosmic chemistry. Through these signatures we learn that the young Milky Way was chaotic yet fertile. Streams of gas collided, forming clusters that lived fast and died young. Every death seeded the surroundings with heavier atoms. From those ashes arose the second generation. Smaller, longer-lived stars that could endure to this day. One of them might once have been the parent of our Sun's own ancestors. Because the Milky Way mixes its stars over time, those early families are now scattered across thousands of light years. But by comparing detailed chemical fingerprints, astronomers hope to identify the Sun's long-lost siblings, stars that formed from the same cloud 4.6 billion years ago, and then drifted apart along the galactic current. Among all these ancient lights, some shine with strange patterns, an excess of carbon, a shortage of magnesium, or ratios of heavy elements that defy expectation. Such anomalies are hints of individual supernovae, each one leaving a unique recipe in its ashes. To read them is to reconstruct the genealogy of the cosmos. Even in our time, new discoveries push the boundary of known age. In the constellation Hydra lies SMSS J03136708, a dim star with almost no metal content at all, less than 1/10,000th that of the Sun. It may be one of the very first generation's children, a direct descendant of the first stars to ever shine. Its continued existence is proof that the earliest epochs still echo within the Milky Way today. Ancient stars are not merely relics. They are the galaxy's foundation stones. Their orbits trace the initial gravitational well that drew matter together. Their chemistry records the earliest enrichments. Their survival shows how durable starlight can be. In the halo, these elders move on elongated paths, sometimes plunging through the disk and emerging on the other side, like comets looping around the Sun. Each passage weaves another thread through the galactic fabric. Collectively, they form a halo of memory, encasing the younger disk in age and wisdom. Between the halo and the disk lies the thick disk population, stars older and richer than those in the halo, but still ancient compared with the thin disk stars of today. They were born during a violent phase of the Milky Way's youth, perhaps triggered by mergers or intense bursts of star formation. Over time, the thick disk settled and thinned, leaving behind the calmer structure we now inhabit. The transition from thick to thin disk marks the moment when the Milky Way shifted from chaos to stability. Before that, collisions were frequent, gas flowed wildly, and new stars ignited in great waves. Afterward, rotation took over, and the galaxy began to spiral gracefully instead of boil. Every ancient light we observe adds a data point to that timeline. By comparing the ages of stars across different regions, astronomers can map the tempo of galactic evolution. where star formation began, paused, and began again. The result is a chronograph etched in starlight, showing bursts, lulls, and recoveries over billions of years. The most ancient stars remind us how small a slice of cosmic history we occupy. They were already old when our solar system formed. They will remain when Earth and the Sun are gone. Their patience is almost beyond imagination. Billions of years of steady fusion, untroubled by anything that happens on the tiny worlds that orbit them. To look at such a star is to feel time itself made visible. Its light began traveling toward us long before there were humans to receive it. Each photon carries not just brightness, but endurance, the persistence of matter across epochs. Through those lights, the galaxy speaks in the language of longevity. It tells us that nothing luminous is truly brief, that even in decay, there is continuity, that the universe remembers everything it has ever made. And so the ancient lights continue to shine, quietly marking the passage of cosmic time, bridging the first dawn of stars to the present spiral night. They are the elders of our galaxy, the keepers of its earliest stories, and the promise that even in the farthest future, somewhere, something will still glow. Chapter 8: Invisible Forces. Not everything that shapes a galaxy can be seen. Beyond the glowing stars, past the swirling clouds of dust and gas, lies a realm ruled by what cannot be touched or photographed. It is invisible, but it binds everything. It is silent, but it moves worlds. It is the framework upon which the Milky Way hangs its light. Astronomers call it dark matter, an unseen mass that outweighs all the stars, all the planets, all the gas combined. It does not shine, it does not absorb, it does not scatter. It passes through ordinary matter as if through air, yet its gravity is unmistakable. Without it, the galaxy would spin apart. In the 1970s, scientists first noticed something strange. Stars at the edge of the Milky Way were moving faster than they should. According to Newton's laws, their orbits should slow with distance, like planets farther from the Sun. But they didn't. They kept pace with the inner stars, as though a hidden hand were pulling them onward. That hand was gravity, but not gravity from visible matter. Something unseen was providing the missing mass. It surrounded the galaxy like a vast cocoon, extending far beyond the last visible stars. This invisible halo of dark matter gives the Milky Way its stability. It holds the arms in place, guides the motion of every cluster, and anchors the delicate balance of the disk. No one knows exactly what dark matter is. Some think it is made of exotic particles, heavy, weakly interacting, and ancient, left over from the first moments after the Big Bang. Others imagine entire families of unseen objects, black holes the size of mountains, or clouds of ultralight fields filling space like mist. Whatever its nature, dark matter remains the quiet architecture of creation. Around this invisible skeleton, ordinary matter gathers, cools, and forms stars. It is as if light itself requires shadow to take shape. The dark provides the scaffolding. The luminous builds upon it. Yet dark matter is only one of the galaxy's unseen players. Threaded through the disk and halo alike is another invisible presence, the magnetic field of the Milky Way. Though unimaginably weak, 1,000,000 times fainter than a refrigerator magnet, it stretches for hundreds of thousands of light years. It loops through the spiral arms, twisting and curving like lines of wind. Where gas clouds move, the field bends with them. Where supernovae explode, it ripples outward, carrying energy through space in waves we cannot see. Astronomers map these fields by their subtle influence on light. When starlight passes through dust aligned by magnetism, its waves become polarized, vibrating in a single direction. By measuring that polarization across the sky, scientists trace the invisible threads that weave through the galactic fabric. The Milky Way's magnetic field does more than decorate the void. It shapes how matter moves. It guides charged particles, electrons, protons, atomic fragments that race through space at nearly the speed of light. These are the cosmic rays, a constant rain of energy falling through the galaxy like invisible drizzle. Most cosmic rays are born in supernova remnants. When a massive star dies, its expanding shock wave whips magnetic fields into tight spirals, flinging particles outward with incredible speed. Those particles wander for millions of years, scattering from field line to field line, until some strike the thin air of Earth's atmosphere, and briefly flash as tiny streaks of light. To the Milky Way, this cosmic radiation is not noise but pressure. The combined force of hot gas, magnetic fields, and cosmic rays helps support the galactic disk. Together they form a delicate balance, a three-way tension that decides where gas can cool, where stars can form, and where winds will rise into the halo. In this sense, magnetism and dark matter serve opposite roles. One provides structure, the other motion. Dark matter holds the galaxy together. Magnetic fields let it breathe. If we could see these fields directly, the sky would glow with filaments and loops. Every nebula would have veins of light running through it. Every spiral arm would shimmer with curved, ghostly lines. It would look less like a machine and more like a living organism. An organism made of starlight and magnetism. Its pulse carried by the flow of energy along invisible nerves. At the galactic center, the magnetic field becomes even more intricate. There, long vertical filaments, each tens of light years tall, rise from the core like luminous threads. They glow in radio light, signatures of electrons spiraling along magnetic paths. No one knows exactly how they form. Perhaps they are sculpted by turbulence. Perhaps they trace the footprints of ancient jets from the central black hole. Whatever their origin, they give the heart of the Milky Way the appearance of an instrument tuned to silence. Farther out, in the spiral arms, magnetic fields follow the same graceful curves as the star lanes themselves. They align with the arms, turning slightly at the edges, as if carried by the same density waves that sculpt the stars. In the spaces between arms, the field becomes more chaotic. a tangle of strands created by stellar winds and supernovae. Even chaos has a pattern when viewed across thousands of light-years. Sometimes, when gas collapses to form stars, magnetic fields resist. They slow the fall, spreading the collapse over longer periods. This moderation keeps the galaxy from forming all its stars at once. It allows the Milky Way to endure for billions of years instead of burning out in a brief blaze. The invisible lines of force are, in their quiet way, guardians of longevity. Other invisible agents move through this space as well. Neutrinos, particles so light that trillions pass through your body every second, without leaving a trace. They are born in the hearts of stars and in cataclysms far beyond. They carry information about processes that no light can reveal, because they slip through matter untouched. Across the galaxy, a steady wind of neutrinos streams outward, the subtlest current in the cosmic sea. Even gravity itself is invisible, its presence revealed only through motion. It sculpts every orbit, warps every path of light, and yet has no form we can see. In the Milky Way, gravity and magnetism intertwine, their interplay deciding where clouds gather, how arms bend, and how the spiral maintains its symmetry. At times, the galaxy releases that stored energy in quiet eruptions. Cosmic rays, gas, and magnetic fields rise together from the disk, forming vast lobes that stretch tens of thousands of light-years above and below the plane. These galactic outflows act as safety valves, venting the energy produced by supernovae and stellar winds. They also carry metals and magnetic fields into the halo, enriching it with the byproducts of star formation. In this way, the invisible becomes the bridge between the visible and the unseen. The invisible forces also record the galaxy's past. In the outer halo, faint ripples in stellar motion reveal where dark matter clumps once drifted through, their gravity leaving lasting scars. Near the center, twisted magnetic loops remember the outbursts of Sagittarius A long ago. The Milky Way forgets nothing. Its invisible fields are its memory, written not in light but in the motion of the unseen. If one could somehow stand far above the galaxy and view it with different eyes, eyes that see gravity, magnetism, and radiation as color, the Milky Way would glow like a woven tapestry. Dark matter would appear as a transparent globe, magnetism as threads of blue light winding through the arms, and cosmic rays as golden sparks flowing outward from supernovae. Everywhere, currents of energy would ebb and flow, slow but unending, balancing creation and destruction in silence. To understand the galaxy, we must accept that most of it is hidden. Only about 5% of its mass shines. The rest is dark matter, hot gas, fields, and energy we can barely detect. And yet, that unseen portion is what gives shape to all we can see. The visible stars are the surface of a much larger structure, a luminous frosting on an invisible cake of matter and force. The next time you look up at the night sky, the faint ribbon of the Milky Way may seem fragile, but beneath that glow lies strength beyond imagining, a web of gravity, magnetic tension, and dark matter. that has held its form for billions of years. That unseen framework allows stars to be born, planets to orbit, and life to look back and wonder what holds it all together. Invisible does not mean absent. It means patient. It means enduring. It means that the quietest forces often shape the grandest structures. Through dark matter's pull, through magnetism's threads, through cosmic rays' endless travel, the Milky Way sustains itself, balanced between chaos and calm, held by powers we can feel only through their harmony. Chapter 9: The Life and Death of Stars. Across the Milky Way, billions of stars flicker in every stage of existence. Some are just beginning, faint knots of gas learning how to glow. Others are ancient giants nearing their end, their light deep and steady like embers in a long-burning fire. Together they create a story older than any world. A slow cycle of birth, brilliance, and return. Stars begin not in brilliance, but in shadow. Deep inside vast clouds of gas and dust, gravity gathers what was once invisible. Atoms drift closer. Heat rises in the core. And for thousands of years the cloud folds in on itself. In the dark, pressure builds until one morning in cosmic time, hydrogen ignites into helium, and a star is born. Most stars are not born alone. They arrive in clusters, families of hundreds or thousands, forming together from the same cold cloud. Their early years are restless. Winds blow, light pushes, and nearby siblings jostle for space. The youngest are surrounded by thin disks of dust and gas, circling like halos. In those disks, matter sticks together, forming pebbles, then boulders, then planets. A single star can give rise to whole systems of worlds, each one an echo of that first ignition. The newborn stars glow blue-white and fierce. They burn through their fuel quickly, pouring energy into the surrounding space. Their light carves bubbles in the gas, illuminating the remnants of their birth clouds. What was once invisible becomes a glowing nebula, an afterimage of creation. Smaller stars, like our Sun, burn more gently. They can shine for billions of years, steadily converting hydrogen into helium at their cores. Their lives are long and calm, their warmth steady enough for planets to flourish nearby. For such stars, life is not a blaze but a quiet endurance. Each star's path depends on its mass. The heavy ones live fast and end suddenly. The light ones drift through ages almost without change. A massive blue star may survive only a few million years. A brief spark compared with the galaxy's age. A red dwarf can last 1 trillion years or more. Its fuel burning so slowly that the universe itself will fade before it does. When a star nears the end of its supply, its story changes. For a star like the Sun, the core runs out of hydrogen and begins to contract. The outer layers expand, turning the star into a red giant, a vast, cool sphere hundreds of times its original size. Its color shifts to deep orange. Its brightness swells until it outshines whole clusters. In that swollen state, the star sheds its outer layers into space. Gentle winds carry away gas and dust, forming delicate shells around the fading core. These shells glow in blues, greens, and violets, illuminated by the leftover heat within. Astronomers call them planetary nebulae, though they have nothing to do with planets, just the roundness of their form. At the center of each nebula remains a white dwarf, a dense ember about the size of Earth, containing as much mass as the Sun. It no longer fuses new elements. It only cools, slowly fading over billions of years, until it becomes a black dwarf, cold and dark. None yet exist. The universe is not old enough for time to have made one. The deaths of massive stars are very different. When their cores exhaust their fuel, gravity takes over all at once. The core collapses, temperatures rise to billions of degrees, and the outer layers rebound in a sudden explosion, a supernova. For a few weeks, a single star can outshine an entire galaxy. Its light crosses space, visible from millions of light-years away. What looks like destruction is in truth renewal. That explosion scatters heavy elements into space: carbon, oxygen, iron, gold. Everything solid, everything living, is made from that debris. From a supernova's heart may emerge one of two remnants. If the core is small, it becomes a neutron star, a sphere only 20 kilometers wide, so dense that a teaspoon of its matter would weigh 1 billion tons. It spins rapidly, sometimes hundreds of times each second, sending beams of radiation through space like a lighthouse. When those beams sweep across Earth, we see them as pulses, regular, rhythmic, the heartbeat of a dead star still keeping time. If the core is heavier still, it collapses completely, beyond atoms, beyond light, into a black hole. Its gravity becomes a one-way door. Matter falls in, but nothing escapes. Black holes can be small, or they can grow by swallowing gas and stars, becoming titans that shape entire galaxies. Each supernova leaves a cloud behind, a glowing remnant of shock waves and dust. Some expand for thousands of years, turning into intricate shapes of color and motion. The Crab Nebula, born from a supernova seen on Earth in 1054, still expands today, its filaments glowing in X-rays and radiolight. Inside it spins a neutron star, a remnant that flashes 30 times a second. All of this, birth, death, rebirth, is the galaxy's way of breathing. Every star that dies gives back what it once borrowed. Hydrogen becomes helium, helium becomes carbon and oxygen, and those elements are carried away to form new clouds. The next generation of stars inherits that material, adding their own light and continuing the cycle. The Milky Way's composition changes with every generation. The first stars contained almost nothing but hydrogen and helium. The later ones carry traces of metals, the fingerprints of earlier explosions. Our Sun, rich in those heavy elements, is a third-generation star, born from the ashes of two previous eras. The Earth itself, and everything that lives upon it, is built from recycled starlight. The galaxy is filled with regions where this cycle is vividly visible. In the Carina Nebula, massive young stars sculpt pillars of gas with their radiation. At the same time, older stars within the same region explode and feed those clouds anew. Creation and destruction share the same sky, each depending on the other. Between the stars, the debris of countless lives accumulates. Dust grains, carbon, silicates, ice, float through space, forming the interstellar medium. These tiny particles are the seeds of future worlds. When they gather in dense regions, they block starlight, forming dark nebulae that look like holes in the Milky Way's glow. But within those shadows, new suns are preparing to rise. Even now, the galaxy is forming roughly one new star every year. It sounds modest compared to its total population, but in cosmic terms it is steady, sustainable, a quiet rhythm that will continue for billions more years. In time, the supply of gas will thin. Supernovae will grow rarer. The Milky Way will age gracefully, its bright young stars giving way to older, redder populations. The galaxy will enter a long evening of light, a slow sunset that will last for trillions of years. Long after that, when new star birth finally stops, the remaining red dwarfs will continue to glow. They will be small, but enduring, tiny candles in the growing dark. The galaxy's light will fade, but never vanish completely. There will always be a few stars left, patiently keeping vigil in the silence of deep time. To imagine the life of a star is to understand the patience of the universe. Nothing is rushed, nothing wasted. Matter simply changes form, again and again, until even the heaviest atoms have had their turn at shining. Our sun, too, will someday expand and shed its layers. Its light will fade, its remains cooling into a white dwarf that will quietly persist for ages beyond reckoning. By then, Earth will be gone, its atoms scattered, its dust perhaps joining a future nebula, helping to build another star far away. And so the story continues, not as a cycle that repeats perfectly, but as a spiral, ever-changing, ever-evolving, carrying the memory of every generation within it. In the end, the galaxy's beauty is not in its permanence, but in its continuity. Every star is a sentence in an unending book. Some burn brightly and finish quickly. Others whisper for eons. But together they tell one long, peaceful story, that everything luminous eventually returns to the dark. And from that darkness, light is born again. That is how the Milky Way breathes. That is how it dreams. That is how it endures. Chapter 10. The Family of the Milky Way. The Milky Way drifts through space not as a lonely wanderer, but as part of a small, luminous family. Around it, companions circle quietly, each with its own rhythm, its own light, its own history. Together they form the local group, a gathering of galaxies bound by gravity, moving slowly through the great cosmic sea. From the outer halo of our galaxy, the first of these companions come into view. Tiny dwarf galaxies, some no larger than a single globular cluster. They move on elongated orbits, some falling inward, others receding. Their light is faint, their stars old, but they whisper of a shared past, of collisions, of capture, of long companionship. Two of the most visible members of this group are the large and small Magellanic Clouds. From the southern hemisphere, they appear as pale smudges in the night sky, just off the Milky Way's bright band. To the eye they seem close, but in truth they lie nearly 200,000 light-years away, circling our galaxy like quiet moons. The large Magellanic Cloud, a swirling patch of gas and stars, is home to thousands of star clusters and glowing nebulae. Its most brilliant feature is the Tarantula Nebula, a vast, pink-gold storm of gas, where new stars are born in bursts so intense they rival whole galaxies in brightness. Inside it, massive clusters form, their winds sculpting arcs and cavities. In the surrounding cloud, it is a microcosm of creation, a smaller reflection of what happens in our own spiral arms. Its companion, the small Magellanic Cloud, is dimmer, its structure more irregular, as though it has been tugged and reshaped by the Milky Way's gravity. Between the two clouds stretches a faint bridge of hydrogen gas, a sign that they interact not just with us, but with each other. Their dance sends long filaments of matter trailing behind them. The Magellanic Stream, which arcs across the southern sky for hundreds of thousands of light-years, that stream slowly drifts inward, feeding the Milky Way with new material, sustaining its star formation far into the future. Farther out, other dwarfs accompany us. The Sagittarius dwarf galaxy winds around the Milky Way's core, in a long, dissolving loop. Each orbit tears more of it away, leaving behind a ribbon of stars that circles our sky like a faint ring. Other satellites, Sculptor, Draco, Ursa Minor, Carina, Fornax, move through the halo in silence. Their shapes faint, their stars sparse. Some may one day vanish completely, their contents absorbed into the Milky Way's glow. Together these small companions form a retinue, a cluster of faint, loyal lights that follow the Milky Way as it travels through space. They are bound not by force, but by time, by billions of years of shared motion through the dark. And beyond them, the family extends. 2.5 million light-years away lies Andromeda, our great sibling. It shines faintly in the northern sky, visible to the naked eye as a tiny blur in the constellation that bears its name. Through a telescope, its spiral form unfurls. Arms of stars, lanes of dust. A glowing nucleus with its own black hole at the heart. It is roughly 1/3 larger than the Milky Way, and brighter by far. Between us and Andromeda, gravity keeps a promise. The two galaxies are falling toward one another, their halos already touching. They will merge billions of years from now, their stars mingling in a slow, luminous embrace. That coming union will reshape the local group, turning two great spirals into a single, serene elliptical galaxy. For now, they are companions across distance, moving together through space, each attended by its own cluster of satellites, each tracing arcs around the shared center of gravity that binds the entire local group. The third major member of this family is the Triangulum galaxy, a smaller spiral about 3 million light-years away. It lies near Andromeda, and may even be its satellite, connected by thin bridges of gas. Its blue arms gleam with newborn stars, its disk open and loosely wound. It is a reminder of youth in a gathering of elders, a smaller, lively cousin, orbiting quietly at the edge of the family circle. Around these three main galaxies, the Milky Way, Andromeda, and Triangulum, orbit dozens of dwarfs, forming a cloud of companions extending over 10 million light-years of space. Together, they drift through the void as one loose, gravitationally bound group. Their collective mass is immense, but their motion is gentle, a slow drift toward the center of the local supercluster, led by the pull of gravity's invisible thread. Within this vast but quiet community, each galaxy lives its own version of the same story: birth, aging, renewal. Each has its own star-forming regions, its own outflows of gas, its own satellites and streams. The local group is a neighborhood not of noise, but of harmony. If we could see it from afar, the Milky Way and Andromeda would appear like twin lanterns glowing within a loose web of smaller sparks. Between them, faint filaments of dark matter and gas connect one to the other. It is through these bridges that galaxies exchange material, a slow trade of hydrogen and metals that keeps them nourished. Every few 100 million years, a small galaxy wanders too close to one of the giants. Tides stretch it thin. Its stars scatter into long streams. The Milky Way grows by such quiet gatherings, its family changing but never shrinking. In this way, the local group is not static but evolving, a living system bound together by attraction and memory. At its center lies not a single object, but a balance point in space, where the pulls of all the galaxies meet. They orbit this shared center, their motions intertwined like dancers in a slow waltz. No one galaxy leads. Each responds to the others, turning together in the grand, patient rhythm of the universe. Even the empty regions between them are not truly empty. They are filled with faint gas, radiation, and the dark matter halo that encompasses the entire local group. That invisible web is the glue of the family, an unseen framework that links each member and defines their shared destiny. Beyond this small group lies a wider network, the Virgo supercluster, a region containing tens of thousands of galaxies. Our local group lies on one of its outer filaments, connected like a bead on a thread of light. From there, gravity pulls us toward a still larger congregation called the Laniakea supercluster, a flow of matter that stretches across 500 million light-years. And even that structure is only one among many. The universe is a family of families, each bound to the next, all part of the same invisible order. When astronomers map this cosmic web, they find that galaxies are not scattered at random. They cluster along filaments, leaving wide voids between them, bubbles of nothingness, surrounded by strands of light. Our Milky Way rides one such strand, flowing along it like a pearl on a thread. Through that connection, we are linked to every other galaxy that has ever formed. In the local group, distances are vast, but the forces that bind them are subtle and enduring. No voice can carry across such space, yet gravity speaks fluently there. It holds everything in conversation, a constant exchange of energy and motion that has lasted since the universe was young. If you could drift outside it all and watch the local group from afar, you would see a cluster of tiny galaxies moving together, each trailing delicate streams of stars. The Milky Way would appear as a soft spiral of light, Andromeda brighter still beside it, the triangulum faintly glowing nearby. Around them, small companions would shimmer, like sparks caught in a slow, unseen current. The entire group would look fragile, as though it could dissolve at a breath. And yet it has endured for billions of years, and will endure for billions more. This is the Milky Way's true family, a quiet network of neighbors, connected not by proximity, but by time, motion, and gravity's patience. They drift together through the dark, each carrying its own stories of creation and change, each adding to the shared light of the cosmos. When we look up at the night sky, the faint band of the Milky Way reminds us of home. But beyond that band, beyond even the last visible stars, our siblings shine. Their light has traveled millions of years to reach us, and in that journey lies the echo of our kinship. We are not alone in space. We never were. We are one member of a vast, quiet family, turning together through the long and patient dark. Chapter 11: The Edge of the Galaxy. Every home has an edge, a place where its presence fades into something larger. For the Milky Way, that edge is not sharp or final. It is a slow fading of light, a thinning of stars, a gradual surrender to the dark. If the heart of our galaxy is a bright city of suns, then its outskirts are the quiet countryside, a realm of emptiness where stars grow sparse and space begins to reclaim its solitude. Here, on the far rim of the Milky Way, the patterns we know dissolve into soft uncertainty. The galaxy's luminous disk stretches nearly 100,000 light-years across, but the true reach of its influence extends far beyond that, perhaps 300,000 light-years or more. When the faint halo of gas and dark matter is counted, the edge of the Milky Way is therefore not a border, but a transition, where gravity loosens its hold, and the stars begin to drift more freely. If you could travel outward from our sun, past the spiral arms, past the last glowing clusters, you would begin to notice the stars thinning around you. The night sky would dim, the familiar Milky Way band softening behind your ship, until it looked like a distant mist. Eventually, the stars would appear scattered, no longer part of a continuous pattern, but islands of light separated by vast darkness. These are the outer reaches of the galactic disk, a region few telescopes can map clearly. Here the hydrogen gas is cold and faint, visible only in long radio waves. By tracing that radio glow, astronomers discovered that the disk does not lie flat. It bends and twists, warped into a gentle S-shape, one edge curling upward, the other dipping below the galactic plane. This warp extends thousands of light-years above and below the main disk. It may have been shaped by the pull of passing galaxies, perhaps the Magellanic Clouds or the Sagittarius Dwarf, whose gravity tugs at the Milky Way's outer gas like a tide. Over billions of years, those tides have left a graceful twist in the disk, turning it from a flat wheel into a slow-moving wave. Beyond the warp, the galaxy continues into what astronomers call the outer disk. Here the stars are older, their orbits more elongated, their numbers thinning with distance. Yet even at these faint edges, star formation persists. Small, isolated clusters and cool hydrogen clouds quietly give rise to new suns. The outer disk is not lifeless. It is simply patient. One of the most mysterious features of the outer galaxy is a vast structure known as the Monoceros Ring. It arcs around the Milky Way like a ripple in water, made of stars that seem displaced from the main disk. Some scientists think it might be the remnant of a dwarf galaxy that merged with ours long ago, its stars stretched into a giant ring by gravity's pull. Others believe it is a natural oscillation of the disk itself, a resonance created when the Milky Way was struck by a smaller companion. Either way, it shows that even at the edge, the galaxy is not still. It breathes, flexes, and remembers every encounter. Farther out still lie faint streams of stars, barely visible even through the most powerful telescopes. These streams are remnants of ancient collisions, stellar rivers left behind by smaller galaxies that fell into ours. Each stream traces an orbit through the halo, a soft filament of memory wrapping around the galaxy's body. Together they form a network of faint bridges, connecting the disk to the deep halo beyond. The outermost stars of the Milky Way move at astonishing speeds, hundreds of kilometers per second. Yet their orbits are vast, taking billions of years to complete. Some are so far away that they feel the pull not only of our galaxy, but also of the distant Andromeda galaxy. They live in the borderlands, where two great gravitational realms begin to overlap. Among these border stars are a few wanderers, hypervelocity stars, flung outward from the galactic center. By close encounters with the central black hole, they race toward intergalactic space at thousands of kilometers per second, fast enough to escape the Milky Way entirely. For them, the edge is not a destination but a departure. They will spend eternity traveling the cold corridors between galaxies, their light fading but never ceasing. The outer rim also hosts high-velocity clouds, immense pockets of gas rushing toward the galaxy. Some are leftovers from ancient mergers. Others are fresh infall from intergalactic space. when they strike the outer disk. They may compress gas and trigger new waves of star formation. Even at its borders, the Milky Way is nourished by the universe around it. The temperature, pressure, and composition of the outer regions differ from the busy inner disk. Here, the gas is thin, the magnetic fields weaker, and cosmic rays less intense. Silence reigns. But that silence is not emptiness. It is balance. In the deep outskirts, gravity, motion, and pressure exist in perfect equilibrium. If you could look back toward the center from this distance, the Milky Way would appear breathtaking. The core would glow gold, the spiral arms silver blue, the dust lanes tracing delicate shadows through the light. Around the bright disk would shimmer a faint halo, its glow barely perceptible, like fog lit by starlight. And beyond that glow, nothing, the endless dark of intergalactic space. At this frontier, the density of stars drops so low that you might travel 100 light-years before passing another sun. Planets, if any, would orbit in silence, their skies dark and still. The constellations we know from Earth would no longer exist, the familiar patterns stretched and broken by perspective. It would be like standing at the edge of a great ocean, watching the horizon vanish into infinity. Here, even time feels different. The outer disk rotates more slowly, its stars lagging behind those closer to the center. A full orbit at the edge might take 500 million years. The seasons of such stars are epochs. What seems eternal to us is only a brief turn of the wheel to them. The Milky Way's gravitational boundary, the point where its pull gives way to the larger universe, marks the edge of its influence, not its light. That boundary is known as the virial radius, a sphere roughly 1 million light-years wide. Within it, the galaxy's matter and energy hold together as one system. Beyond it, other galaxies' halos begin. Our Milky Way's halo already overlaps with Andromeda's, a gentle mingling of invisible matter across the void. Somewhere within this overlapping space, the future Milkdromeda galaxy is already taking shape, its edges knitting together molecule by molecule, star by drifting star. It is a quiet union, beginning long before the visible merger to come. In the outskirts of the Milky Way, astronomers have found rogue planets, worlds without stars, drifting through the dark between systems. They may have been flung from their birthplaces by gravitational interactions, or perhaps they formed alone, their warmth sustained only by internal heat. Each one is a silent traveler, a tiny echo of the galaxy's restless motion. Dust grains also roam these regions, carried by stellar winds and outflows from dying stars. Over time, that dust becomes part of the intergalactic medium, spreading the galaxy's chemistry outward, seeding space with carbon and silicate, the ingredients of life, drifting far beyond the places where life has ever existed. At the farthest limits, the Milky Way blurs into background radiation, the faint afterglow of the Big Bang. Here, starlight mingles with that ancient relic, and the distinction between galaxy and universe dissolves. Our home becomes one thread in a larger tapestry, no longer a separate island, but part of the great cosmic sea. To think of the galaxy's edge is to think of impermanence. There is no line, no fence, no border, only transition, only the gentle fading of one thing into another. If the Milky Way had a sound, its center would hum with energy, its arms would whisper with star birth, and its edge would be silent, a pause between verses, a breath before the next phrase of eternity. That silence, however, is not emptiness. It is invitation. The edge of the Milky Way is not the end of the story, but the beginning of the next. The place where our galaxy touches the rest of creation. And when we look up from Earth, tracing the faint glow of that galactic band across the sky, we are seeing not the whole, but a thin slice of an infinite structure, a home without walls, without boundaries, whose edges blur into forever. Chapter 12: The Long Night Ahead. Time in the universe does not move as we feel it. It stretches, expands, and deepens, turning seconds into centuries, centuries into ages. Galaxies themselves are clocks, their rotations marking the slow rhythm of cosmic history. And like all clocks, the Milky Way's hands will one day wind down, but not soon. For now, it spins steadily, its stars alive and bright, its arms winding in quiet symmetry. The galaxy is in its middle age, neither young nor dying, balanced between creation and calm. It will remain this way for billions of years yet, a place of light in a universe that is slowly cooling. Even so, the future is already written in the language of motion. Gravity continues its patient work, and the Milky Way's story stretches far beyond any measure of human time. In about 4 billion years, the first act of that future will unfold, the meeting with Andromeda. By then, the sun will be near the end of its life, its light softer, its warmth fading as it expands into a red giant. Earth, if it still exists, will be scorched and empty, its oceans long gone, its continents turned to glass. But above that silent world, the sky will be magnificent. Andromeda, now filling much of the heavens, will glow brighter than the full moon, its spiral arms stretching from horizon to horizon. Over millions of years, it will drift closer, its shape elongating, its stars scattering into arcs of gold and blue. Then, slowly, the two galaxies will merge, not with violence, but with grace. Stars will pass through stars, clouds will intertwine, and the night sky will bloom into rivers of light. It will be one of the grandest sights the cosmos can offer, the merging of two great spirals into one. When the encounter is complete, a new galaxy will be born, an enormous, rounded form glowing softly with old light. Astronomers call it Milkdromeda, a single, tranquil giant that will rotate for eons, as the universe continues to expand around it. For a time, star formation will flourish again. The collision will compress gas clouds, igniting fresh waves of birth. New suns will light up the merged halo, their planets beginning their own small histories. But eventually, the fuel will thin. Hydrogen will grow scarce, and the galaxy will enter a long twilight. Over tens of billions of years, the bright blue stars will vanish first, short-lived and extravagant, burning their lives in a fraction of a cosmic heartbeat. The smaller, redder stars will remain, shining faintly in the darkening sky. The spiral pattern will dissolve, leaving a smooth, oval glow, a calm, elliptical galaxy resting in the stillness of age. By then, the universe itself will have changed. The cosmic expansion will have carried other galaxies beyond sight. The night sky will no longer hold countless points of light. Only the merged Milky Way will remain visible, an island of stars adrift in darkness. Future astronomers, if any remain, will see no evidence of a universe beyond their own. They will think the cosmos ends with their galaxy, never knowing how vast it once was. Time will continue. Trillions of years will pass. Stars like the sun will have died, leaving behind white dwarfs, tiny, cooling embers glowing in infrared. Others will collapse into neutron stars or black holes, their gravity eternal even when their light has gone. The galaxy will become a constellation of ghosts, each one a remnant of a past era. Slowly, the remaining red dwarfs, those quiet, thrifty suns that live the longest, will burn through their fuel. They will fade to brown, then to black, their light extinguished but their mass still present. The Milky Way's glow will dim until only a few scattered points remain. Even then, the galaxy's heartbeat will continue, not through light, but through gravity. Its stars, remnants, and dark matter will keep orbiting the central black hole, which by then may weigh tens of millions of solar masses. It will not shine. It will simply exist, a point of infinite calm at the center of an infinite quiet. Beyond that lies a time so long it defeats imagination. After 100 trillion years, no new stars will form anywhere. The universe will enter what scientists call the degenerate era. An age when all that remains are the remnants of former suns, white dwarfs, neutron stars, black holes, and cold planets. The cosmic night will deepen, but it will not be empty. Matter will still orbit. Energy will still flow, though imperceptibly slowly. Even black holes, the most enduring objects of all, will not last forever. They will evaporate through a process called Hawking radiation, losing mass one quantum at a time. The Milky Way's central black hole will vanish last of all, releasing its final whisper of energy, in a burst so faint no eye will ever see it. After that, only the fabric of space-time will remain, cold, vast, and quiet beyond description. The story of the Milky Way will be complete, its light long spent, its matter dissolved into the gentle drift of eternity. But perhaps the truest beauty of this ending is that it mirrors its beginning. The galaxy was born from darkness, and to darkness it will return. What happens in between? The spirals, the stars, the brief blaze of worlds, is the miracle we are part of now. From the atoms in our bodies, to the light that warms our days, every piece of us once belonged to this galaxy's cycle of birth and death. We are the living proof that the Milky Way's long story reached this chapter. And though our time within it is short, our connection to it is eternal. For even when the last star fades, its light will have traveled onward, across distances so vast that time itself seems to pause. Those photons will continue to move, each one carrying a record of where it came from. The glow of the Milky Way will not vanish suddenly. It will spread thin, diluted across the cosmos, lingering like memory, somewhere far in the deep future. When all other light has gone, those last wandering photons will still be traveling, each one a fragment of this galaxy's long and quiet life. That is how the universe remembers, not through permanence, but through persistence, through motion that never fully stops, and light that never truly ends. To think of the Milky Way's far future is not to feel sadness, but peace, because its destiny is the same as everything that has ever lived: to shine for a while, to give warmth, to leave something behind, and then to rest. In that cosmic rest, there is no loneliness, only stillness, only the soft hum of space expanding, carrying with it the memory of all that ever was. So as we look up tonight, at the faint arch of the Milky Way across the sky, we are seeing a moment in a much longer song, a single verse in a melody that began before life, and will echo long after light itself fades. And in that vastness, in that unending quiet, there is comfort. For though the stars may die, their story will continue, written forever in the deep, calm night ahead. Chapter 13. The Long Night Ahead. Long before we built telescopes, long before we named the stars, the Milky Way was already watching us. It stretched quietly over sleeping forests, over oceans that reflected its silver glow, over deserts where travelers followed its faint arc like a road across eternity. To those first eyes, it was a mystery, a cloud of light, a river in the sky, a path for souls, or milk spilled by the gods, or the seam that stitched heaven to the earth. Every culture saw something sacred in that hazy band, and perhaps they were right, for what they were really seeing was the sum of everything we now know to be home. The first astronomers had only their senses and patience. They traced the constellations along that bright arch, measured how it shifted with the seasons, and noticed that the planets never strayed far from it. The ancients understood, somehow, that this glowing strip marked the plane of something vast. It wasn't until 1610, when Galileo lifted a small telescope toward that band, that the secret began to unfold. He found that the Milky Way was not a cloud at all, but a multitude of stars too faint to see individually. He counted thousands in a single patch, each one a tiny sun. The sky had deepened, from surface to dimension, from myth to infinity. 3 centuries later, astronomers began to map it in earnest, using careful measurements of brightness and distance. They tried to reconstruct the galaxy's shape from within. It was like trying to draw the outline of a forest, while standing among its trees. Dust obscured their vision, and for a long time, the true structure of the Milky Way remained hidden. Then, in the early 20th century, came a quiet revolution. An astronomer named Henrietta Leavitt discovered that certain stars, Cepheid variables, pulsed with a rhythm that revealed their true brightness. By comparing how bright they appeared from Earth, scientists could determine their distance. The universe suddenly had a ruler. With that tool, Harlow Shapley measured the distribution of globular clusters, ancient spheres of stars orbiting far above the galactic plane. He noticed that they weren't centered on the Sun, but offset by tens of thousands of light-years. From that clue, he deduced something humbling. We were not at the center of the Milky Way. Our solar system lived in a quiet suburb, halfway to the edge. The cosmos had shifted its perspective once again. Later, with radio astronomy, the invisible became visible. After World War II, scientists tuned antennas to the 21-centimeter wavelength, the signature of neutral hydrogen. Suddenly the galaxy appeared in full. Arm by arm, curve by curve, the Milky Way revealed its spiral form. It was as though the heavens had finally allowed us a map of home. Then came infrared eyes, piercing the veils of dust. Space telescopes like Spitzer and Wise showed the hidden heart of the galaxy glowing in warm light. Stars that had been obscured for millennia now shimmered in view, tracing the elegant bar across the center and the curling arms beyond. In the 21st century, the Gaia spacecraft began its grand survey. From its orbit around the Sun, it measures the positions and motions of nearly 2 billion stars, an astronomical census unlike any before. With that data, astronomers can watch the Milky Way breathe. They can see ripples in the disk, streams of stars falling through the halo, and the subtle rotation of the spiral pattern itself. For the first time, we can see our galaxy not as a picture, but as a living, moving thing. Through Gaia's precision, we've learned that the Milky Way once devoured smaller galaxies, their stars now woven into our own. We've traced our Sun's orbit over hundreds of millions of years, and discovered that the disk itself vibrates, its stars rising and falling like the surface of a great sea. We've measured the faint polarization of starlight, mapping magnetic fields that twist through the arms. We've detected streams of dark matter through gravitational lensing, seen radio filaments curling around the center, and watched clouds of molecular gas collapse to form new suns. Each observation opens another window, and through those windows, the galaxy becomes not just a place, but a process, a vast, continuous act of creation. If the galaxy were scaled down to the size of Earth, our telescopes would still see less than the surface of a fingernail. and yet from that fragment, we've built a portrait that reaches across time. We've seen the stars of the halo orbit for 10 billion years. We've traced the echo of the Fermi bubbles, remnants of an outburst from the central black hole millions of years ago. We've even begun to detect faint ripples in spacetime, gravitational waves, produced when compact stars spiral together within our own galaxy. The Milky Way is not silent. We are only now learning to hear it. Astronomy has always been an act of listening to distance. Every photon that reaches our instruments is ancient history. The light we see from the center tonight, left there 26,000 years ago, before the first cities, before language as we know it. Each observation is therefore a message from the past, arriving in the present to tell us who we are. Even the night sky we see with our eyes is already old light. Some of the faintest stars we glimpse may no longer exist. Their deaths are long over, their remnants already cooled, but their light continues to travel, crossing the gulf like a final word. Through these windows, we begin to sense not only the structure of the Milky Way, but its continuity, how every particle and photon participates in a vast conversation, from the birth cries of newborn stars to the X-ray sighs of dying ones. The galaxy speaks in every wavelength. Our instruments are translators, turning radio pulses into sound, infrared warmth into color, gamma rays into patterns of meaning. In this way, we are learning to see with all the senses the universe allows. And as we do, the Milky Way ceases to be distant. It becomes intimate, a landscape we can almost touch. Consider this. The radio waves that reveal hydrogen in the outer disk pass freely through the walls of our homes. They are here right now, washing through the air we breathe. We are surrounded by the quiet music of our galaxy. We simply lack the ears to hear it directly. Even our planet carries traces of that cosmic song. Microscopic grains in ancient meteorites contain isotopes forged in long-dead stars. Atoms of calcium in our bones once existed in the heart of a red giant. When we look up, we are not gazing outward. We are recognizing ourselves in the mirror of space. Every discovery adds depth to that reflection. Infrared telescopes reveal new stars still shrouded in birth clouds. X-ray observatories show the high-energy glow of black holes feeding in silence. Gamma-ray detectors find bursts from distant magnetars, each one a flicker in the galactic storm. The Milky Way is no longer a static backdrop for our lives. It is a living ecosystem of light and gravity, constantly in motion, constantly renewing itself. The more we learn, the more we realize how connected everything is. The winds from massive stars enrich the next generation of clouds. Supernovae spread the seeds of new chemistry. Black holes sculpt their surroundings, regulating how stars form in the disk. Even dark matter, invisible and quiet, determines the very rhythm of this cosmic heartbeat. And through all this, the earth keeps turning beneath it, a single pebble caught in the stream. From here, under this sky. We see only the nearest ripples of that flow. But through our instruments, our radio dishes, our space telescopes, our observatories on mountain peaks, we can look beyond the surface and glimpse the true depth of home. There is poetry in this pursuit. Each image, each data point, is a way of touching something unreachable. To map the Milky Way is to trace our own origins, to follow the light backward through time until it becomes silence again. And though we can measure its age and motion, there remains one truth science cannot dissolve: the feeling of belonging, that sense, deep and wordless, that we are part of something immeasurably vast yet familiar. When we stand beneath the Milky Way, we feel not small, but included, a note within a symphony that began before us, and will continue long after we are gone. Perhaps that is why so many find comfort in its sight. It reminds us that change need not be chaos, that endings are also beginnings, and that even in darkness, beauty endures. The Milky Way has been here since before our species existed. It will outlast our civilizations, our languages, our memories. Yet the trace of our looking, the act of observing, will have been part of its story too. For once in its long life, it created a world that could look back and understand. And that, maybe, is the most beautiful fact of all. That out of its dust came eyes that could see it, minds that could map it, and hearts that could find peace beneath its glow. We are the galaxy thinking of itself, the Milky Way dreaming in human form. And even when our lights are gone, the record of our gaze will linger. Data stored in satellites, signals traveling outward, echoes of curiosity expanding with the same universe that bore us. The stars may not know we were here, but their light will always know us. It shaped us, and through it, we continue to shine back. The windows to the galaxy remain open, in every wavelength, in every moment of wonder. All we have to do is look, and listen, and let the quiet voice of the Milky Way remind us that home is larger than we ever imagined, and that it is always, always, right above us. Beneath every patch of darkness, something is glowing, turning, and reaching across the void. As the night deepens, imagine that great spiral surrounding you. The stars breathing, the dust drifting, the galaxy alive with quiet motion. Light becomes memory. Motion becomes stillness. And all of it turns together in perfect calm. Let that vastness wrap around you like a gentle tide, soft and weightless. Let your breathing slow, steady, and deep. If you enjoy these quiet journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here, too. One sleepy soul at a time. For now, just breathe. Let your eyes grow heavy and let the ancient light of the galaxy cradle your thoughts.